Ladies and gentlemen, we're about to start.
Ladies and gentlemen, good evening. We're the Italian Society of Imperial College, and we would like to thank you for showing so much interest in our event. Now, without further ado, I am honored to introduce the Italian ambassador in the UK, His Excellency Pasquale Terracciano.
Well, ladies and gentlemen, I would like to thank, first of all, Professor Maria Chiara Carrozza from the Scuola Superiore Sant'Anna di Pisa, and I'm delighted that she has been able to come to London to give this talk. And I would also like to thank Professor Guangzhong Yang, Director of the Hamlin Center, for his participation to this event. And many thanks also to the Italian Society at the Imperial College and to General Roberto Vittori for organizing the event in collaboration with my embassy. In introducing Professor Carrozza, let me say that we have with us tonight an impressive and unusual combination of an outstanding scientist and a brilliant politician. Professor Carrozza teaches at the Scuola Superiore Sant'Anna di Pisa, an internationally recognized and most prestigious Italian university. The Scuola Superiore Sant'Anna is a special statute public university located in Pisa, operating in the field of applied sciences. The Sant'Anna has a long history with roots going back to the 14th century. The present status of the Sant'Anna has been modeled on the Scuola Normale Superiore di Pisa. And let me explain here that, just for the English ears, that normale here is not derogatory, is not just no ordinary school, but comes from Latin, comes from norma, which is the standard, the rule. So the scuola normale is the scuola that was meant to set standards to the scientific research. And Professor Carrozza is at present full professor of industrial bioengineering at Sant'Anna. She has been rector of the Sant'Anna, and she holds the record of having been the youngest rector in an Italian university. She has also served as Minister of Education, University and Research from April 2013 to February 2014. And in 2013, she was elected to the Italian Parliament, of which she's still a member. As I mentioned, Professor Carrozza is an outstanding scientist. I will touch on just a few of her important appointments in this role. She's member of several prestigious scientific societies, of the Engineering Evaluation Panel of the European Research Council, of the International Evaluation Committee of the Excellence Initiative of the German Federal Ministry of Education and Research, and the German Research Foundation for the Neuro-Robotic area. She also participates in the academic life of university in Germany and down under in New Zealand. In conclusion, we have with us this evening a very distinguished scientist who has also made a significant impact on the Italian university system. She will talk to us tonight about robotic technologies, from space research to Earth applications. I believe that this will be an example in the specific field of robotics on how basic research can produce applications that impact on our everyday life. Such translational research is a very well-established concept here in the UK, as was indicated by the important document of the previous government, Cameron government, entitled Our Plan for Growth, Science and Innovation. But innovation cannot occur without knowledge and vice versa. Basic research can be greatly stimulated by the demand that come from the needs of novel products or processes. In order to achieve this objective, a positive dynamic between the private sector and research institutions is required. And we also need greater cooperation at European level if we want to compete globally, particularly in this field. And of course, there are political implications of what I've just said, on which I will not dwell. But you can imagine what is my opinion on this. It is therefore, anyway, and my hope that this event will open the way to an increased collaboration between Imperial College and Scuola Superiore Sant'Anna and other qualified Italian institutions operating in the field of robotics. So I would like now to leave the floor to Professor Guanzhong Yang, Director of the Hamlin Center here at Imperial College. Thank you very much.
Thank you, Your Excellency, ladies and gentlemen. So it's my great honor to say a few words about today's event. So today's event is organized by the Italian Society at the Imperial College. And as you know, that robotics is regarded as one of the 8 great technologies the UK government see it to drive the economy, drive the knowledge base, and also drive the societal impact. And robotics naturally is a very diversified field, and being the member of the Italian Society, I'm sure, or a friend of the Italian Society, I'm sure you all come from different disciplines. In fact, recently that the areas covered by robotics, really not only the mechatronics, the control, the navigation, the visualization, AI, machine learning, but also cover material science, because as you drive the robots from deep sea exploration to space missions, today we have here your distinguished Italian astronaut, Roberto Viteri, and also that his son, and Eduardo, in fact, is the person right behind this whole event. As you can see, that the robot is really become ubiquitous. It's going to affect many aspects of our life. Today, we have the honor to have the distinguished lecture to not only to address the scientific progress and also advances in terms of wearable robotics, but also she's going to touch upon the economic, the societal impact, and also ethical considerations. Responsible innovation is something we all try to address nowadays. And in today, perhaps, is the right forum for us to discuss all these issues. And I very much hope that you will enjoy today's event and also seed new network and new friends. What I would like to say is really 2 more things. One is in the UK, we have this UK Robotics and Autonomous Systems Network. Our idea is really to not only to bring all the universities in the UK working in robotics and automation together, but also to link with international hubs. And this is really the discussion. We're very much delighted to have the ambassador here to open today's event, and I very much hope we can have the Italian hub linking UK and also Italy. Pursuing engineering, pursuing science, there should be no boundaries. Let's put all the politics aside and unite together to address this important area, and an area I very much hope is the people you hear that will shape it in future. So without further ado, let's invite our distinguished lecturer to come to give us the keynote. Thank you very much.
Thank you very much, Professor Yang, for your enlightening words. Robotics is a very broad field. We will now concentrate and focus on the specific part of the technology that is helping humans with an extension of their operations. The concept of robotic arm will therefore be analyzed in full details, both from the perspective of space operations, but also as an enabler to compensate for impaired body functions. For time constraints, the main focus will be on the second, and the first will just be an introduction that we may have the possibility to expand on in a further occasion. But let me first introduce a short video with greetings from space of the ESA astronaut of UK nationality, Tim Peake.
Hello, planet Earth. I'm British ESA astronaut Tim Beake, here on board the International Space Station. Now, from up here, it's very clear to see how human and robotic exploration can and must work hand in hand. And this International Space Station is a great example of that. I'd love to be with you today to discuss space robotic technologies, but I'm sure that my European Space Agency colleague, Roberto Vittori, who is with you tonight, and he actually manipulated the robotic arm in order to install the alpha magnetic spectrometer on this very space station a few years ago. He'll be able to convince you of the importance of this work. So I'd like to send my best wishes to the Imperial College London, to Professor Carosa, and to all the participants for what I'm sure will be a very fruitful exchange and a great event. So goodbye everybody from space.
It's working? Yeah. Good afternoon, everybody. I will make a short introduction underlining the importance of robotics in space. But before, I have, as usual, I am also a visiting professor, not here, somewhere else. I like to start with a question. I will ask for a volunteer. If there is no volunteer, Professor Young will have to give me the answer. What is the difference between general and astronaut? I am General, Roberto Vittori is astronaut. What is the difference between the terminology, the identifier, general or astronaut? Which one is better? What is the difference? Any volunteer? Raise the hand. There is a rank. That's a good hint. General is something that identifies a military career. That's good and bad. General means that you are somehow important, but you are old. Astronaut instead doesn't present an identifier with time. Once you are astronaut, as long as you show pictures of 20 years ago, there is no time tag attached with the word astronaut. So I like to better be identified as astronaut Roberto Vittori. This is the International Space Station. Currently, in space, human space flight is 99% focusing on the International Space Station that is a $100+ billion investment, common effort between NASA, Russia, Europe, Canada, Japan, and UK now is also important part of it because of your Team Peak astronaut flying space. The majority of the construction of the space station has been done through robotic arm operations. And I had also the opportunity, the privilege to be arm operator myself. So in order to anticipate and introduce Professor Carrozza's speech, I would like to focus on something that is only one example. International Space Station, 100 billion investment. This is our technology outpost to space for future exploration. We strongly, deeply rely on robotic arm operations. Now, if you want to go to space, you have three options. In reality, the first, the shuttle, is now retired. Soyuz is still active, down, it's not very well visible, it's the future. The US are transitioning to new spacecraft. This is not 20 years ago, but close, on board of the International Space Station, microgravity characterized. This beautiful picture, it's the Southern Lights. You see one of the key technology of the ISS, that is the robotic arm. And this is a screenshot of an image of the inside of the control station. Obviously, I could spend hours describing to you. Today, this is only a flavor, and maybe in the future, if you have an interest, there could be an opportunity for me to get into details. Again, today I just want to give you a brief overview and appreciation on, first, robotic operations are key in space. Second, the complexity of it. And to describe about complexity, This is the Canadian arm ready to grapple on the upper part, the so-called grapple fixture. The way we work, the operator is inside the International Space Station, is operating it through cameras that are not very well visible. This is the camera. It is focusing on this part, and you can see the pin that represents the technique that has been used, is used in order to make the robotic arm operations. This is an expanded picture of the grapple fixture. And the way it is mechanized, once the arm is on top of the pin, those nails snap in place and capture the whatever item. This is another image of one of the many operations that we are performing on a daily basis. This is the International Space Station, the robotic arm. This is an approaching vehicle. Some have the capability to dock autonomously, some do not. The ones that do not have an auto-docking capability are engaged, approached by the robotic arm that capture the vehicle to then dock it. I don't wish to take any more time to Professor Carrozza. I have only another short video for you that summarizes what I have done in 2011. One of the roles that I had on board on my third space flight was to attach a large experiment, IMS. So I have a short video, about 2 minutes, that we show. We went up with a shuttle. Inside the bay there was IMS, about 7-ton experiment. And then I took it from the bay with the robotic arm, lifted up, and on the ISS there was a colleague of mine that was operating the other robotic arm from the ISS. And I gave it to them, and then they installed it on the truss of the ISS. I'll show the video and then leave the floor to Professor Carrozza. Let's see. Yeah, the problem is that I don't see it. When you attach the large screen, the characters are so small that I need to guess. This time was a good guess. 2011, International Space Station.
DLC-3, we use the shuttle arm to extract the payload from the shuttle payload bay. We maneuver to, again, a predetermined handoff point.
You see the second robotic arm.
Greg Johnson and Greg Shamtoff, again, on the station arm, maneuver the arm in and grapple the MS payload.
Now the shuttle gets away.
It's complete. The shuttle arm backs off to a viewing position to give us good views of the AMS install operation on the port side, the starboard side of the truss. And at that point, Johnson and Shamtoff carefully maneuver the AMS to its installation side on the truss.
This is the simulation. And now we have images from the real flight.
Thank you, Roberto, for the inspiring images. Now, I am honored to introduce the guest speaker for today. Maria Chiara Carrozza is an Italian scientist and member of the Italian Parliament. She has been Minister for Education, Universities and Research. Welcome, Professor Carrozza, and thank you for accepting our invitation.
It's working. Can you hear me? Okay. So good evening. My name is Chiara. Everybody call me Chiara. And I am, first of all, proud to be here. I would like to thank Professor Young for being here, all colleagues from Imperial College, students, and the Italian Society for inviting me here. For me, it is an honor, and I know Imperial College from its achievement, and for me, it's really a pleasure to try to give a lecture and perspective on the evolution of robotics so far, and try to attract you to enter into robotics and also to think about the possibilities and the opportunities of studying robotics and approaching this area. And first of all, a short disclaimer, I am a member of the Italian Parliament. I am in the Foreign and European Affairs Committee. And I am member of the Biorobotic Institute of Scuola Superiore Sant'Anna in Pisa, Italy. And I am also partner of a startup company in wearable robotics. Its name is UVO, and producing robots for rehabilitation and personal assistance. And also I am a member, elected as independent, of the board of directors of Piaggio company, which is a company manufacturing scooters and small cars. So I'm also now involved in personal mobility tools. And first of all, I will introduce you to the relationship between robotics and the society. And then I will introduce some technical issues related to robotics. But first of all, we have to understand where we are and the scenario that we are facing in robotics. It is impossible to speak about robotics without speaking about the self-driving car. It is important because it is the opportunity for robotics to enter into the civil life, to enter into the society, and to come into our streets, and to take our place in driving car, which is a sort of model of what robotics can produce into the near future. There are many news broadcasting how and making news and announcement and comments on how robotics will bring advantages in entering in our place in driving cars. For example, this is something that was reported on Washington Post, and Washington Post is explaining how self-driving car will produce less car crash, less people injured, cars out of the city centers, and more free time, so a lot of advantages. And I think that these advantages are supporting the idea that we need self-driving car in our cities. And hidden in this history is a very big, huge technological competition. We know that there have been a lot of investment in this area because to replace the driver is not a simple task. And there are some announcement and statement from Google Car, which is the first actor moving in this arena, and they are telling us that they are not replacing the driver, but only assisting him in difficult tasks. But we know that also Toyota joined this technological competition in investing and is willing to invest $1 billion. And some colleagues of us who were used to appear in conferences and presenting papers and being active in the communities are now disappearing in these research centers from Toyota, from Google, and they are doing a lot of research in this development. But as soon as they join this competition, they disappear from science, and we know only that they are working on this field. But in UK, especially in UK, there is a lot of discussion about if the combination of robot and artificial intelligence can replace the driver in a simple way, and especially on, for example, on Financial Times, but on other journals and articles, there is the problem, the issue of moral issues. So the reason why I am trying to introduce you to that issue, the moral issue and the morality of machine, is because if the robot with artificial intelligence, with sensor, with all system is replacing us in driving a car, we must introduce into the robot some moralities in order to provide the robot with rules and to make decisions. So this is the point. The point is that if the robot will enter into the society and replace or assist, or replace and assist the driver in taking the responsibility of driving the car, we have to introduce some morality. And so we have to investigate on what is this morality and which kind of rules we have to implement into the robot in order to be able to decide if hitting a truck or hitting a pedestrian, this is a question that for philosopher has no answer at all. It is impossible to find a solution. Then, very recently, we know that artificial intelligence is providing us with another important result, and which is related to a sort of algorithm from AlphaGoogle, which beat a human professional player of Go. Go is, you know maybe what it is, and you know already this news, but this news is very important because it is producing a lot of expectation on algorithms in deep learning and on the ability of algorithms to solve and beat human players into understanding games and in producing strategies in order to win a game. And this is important and relevant for robotics. Why it is so important? Because as we saw before, the combination of this algorithm with the power of physical machines able to produce force and displacement and movements, they can overcome or support or maybe interact with human beings into the society. So we have some challenges for the society. So from one side, we have this technology push, producing Google self-driving cars, producing algorithms which beat human professional players. From the other side, we have the society. And the society, the political worlds, the governments, producing some demand and also expectation for scientists and for roboticists. The scenario now is that we have a second machine age of the fourth industrial revolution, but a sort of industrial revolution, which is produced by robots, artificial intelligence, technologies like 3D printing and 5G, so connection with zero latency, which basically is the fundamental base for connecting people and transmitting data and providing transparency and also teleoperation. But also there is a strong demand from the society, and I will show you that now scientists are requested to face the challenges of the society. And then there is the problem of canceling or displacing jobs. If I produce a robot which is a competitor of a human worker, we know that the future market jobs will be modified by these robots. And finally, we have the paradigm shift of sustainability. Thermodynamics, as Jeremy Rifkin is telling us, is changing the economic paradigm. We cannot think about technological and industrial development without thinking about the thermodynamical consequences of this development. So the result is that we must be involved in regulatory issues, and the cooperation between scientists and lawmakers will be fundamental. Now, today, and in these days, the European Commission launched an initiative which is called Innovation Deal for lobbying, for including lobbying into the lawmaking process at the European level. So scientists, people from lobbies, people from industries should be involved in the process of producing new law. And we know that civil law on the responsibility of the machine in the society will be requested to develop new regulatory issue in order for us, roboticists, to produce such robots and with success. Then we know that logistics, so the distribution of goods around the night or during the day, will be basically revolutionized by self-driving cars and robots with mobility and also personal mobility. I am part of a company in the board of directors which is involved in that, and we know that the future of personal mobility will be totally different. And now Europe and the European Commission, so I'm not campaigning for the against Brexit, of course, but I am very much European and involved in the process of research and development in Europe, so I will speak for Europe. And we know that in Europe we are now launching this initiative for Factory 4.0, which will be a massive involvement of industrial leadership in investigating how robotics will change the future of manufacturing. So, for example, in producing systems for co-working and for overcoming the aging process of our workers in our companies, or for producing systems, robotic systems, which will replace the human tester in making tests of new devices and new instruments, and in developing product and robots for logistics, as I said before. So this is only to give you the scenario where we are moving and why we are now under the attention of the public in developing robots. And we know that the upcoming industrial revolution is also facing problems related to unsolved scientific question, and even nature. In September 2015, for me, I am now an old scientist, I know that nature is very much involved in basic science, in basic research. But now there was something changed, because even nature told us that scientists must work together to save the world. This is important, because we know that now for you, students in science, in engineering, in biology, in medicine, you have some challenges that people expect that you solve. For example, the Zika virus, the Ebola. Ebola was solved thanks to science and to new data analysis and new international collaboration. And I think that this kind of problems, the starving of people, the climate change, the production of green energy, the boat people migration and similar, we cannot solve without an interdisciplinary approach and without a real international collaboration among different scientists. From the other side, we know, for example, I have a picture from China, because there was an announcement in June 2015 from a company. They are claiming that they have a non-human factory. So robots are producing robots without any human subject. And this was an announcement that impressed me a lot, because it is a sort of paradox. So we produce robots with robots. And we know from forecast and analysis of data that there is an impressive increment of production of robotic or robots for automation. So automation is going forward and forward, and it is becoming more important. I have a video on which is anticipating what is teleoperation. It is clear that now we are able to produce, thanks to the combination of wearable robotics. This is an exoskeleton produced in my institute, and this is a KUKA arm produced in Germany. that we are now able, through this wired system, to teleoperate thanks to advanced control, teleoperate a robot and being able to be compliant in touching and interacting with human body. It is clear that when we will have 5G connection and the ability to have zero latency data transmission, we will be able to control arms in the space or remotely in Africa, in different places, in different countries. So we are now in the place of producing something that for the moment is impossible, teleoperation by means of wearable robotics. Finally, my final point on the perspective of technology is on technology and job market. This is for students who studying economics and business economics. And because we know that it is an old story, that technology is taking job places from the job market. And for example, here, this is a vignette on the wheel. But now there is on the IEEE spectrum, which is a magazine for engineers all around the world. This vignette was putting a robot giving order to a human. The human is not perfect and is doing simple tasks, and the perfect robot is giving and taking control of the situation. So maybe because this is on the engineers magazine, so this impressed me because this means that the engineers have this kind of fear that in future maybe machines will be better. So now, then I will wait for questions and reactions from you on that matters. So the robots are coming. This is one of the studies. Because I am a member of the parliament, I am studying very much this problem of job displacements. And we know that in the future, the head of executives and people in global business services think that process automation by 30% will be one of the technology priority for the future. And we know also that because of cloud computing, maybe 36% of the job will be modified. And there are studies from Oxford, from two scholars in Oxford, and a paper which is very much interesting on how a single job will be modified thanks to process and automation of the process. And I think this is important because it is like studying and making a forecast on how job will be. This will have a tremendous impact on education, especially education in primary school, in high school, but also university education, because we must educate people, because even a lawyer will have to face such kind of process automation into everyday work. And so we have to study maybe how to train and educate people in order to be prepared for such kind of revolution. So this is another perspective on that issue, but I think that is enough. No? Okay. Okay. Limit of technology. Finally, my last slide on that is the correlation between unemployment and robotics. So I suggest a subject for thesis, and especially thesis in economy and in macroeconomy on this correlation, because we know that in different countries we have different data and different outcome, and this is an open issue. We know we need recent and studies on that, because this is an important, I think, ingredient in order to understand and make a forecast on the future. So now I move to robotics and to classification of robotics. And I will take some example of research that is going on in my institute in order to introduce you to technical challenges of robotics. I am professor of biorobotics, so I'm teaching biorobotics, and my research area is biorobotics. And in biorobotics, we have different areas, and we speak about animaloid robotics, so people developing animaloid, humanoid robotics, and wearable and implantable robotics. No. Just a moment. And animaloid robotics is receiving a lot of attention. We have this company, Boston Dynamics, and research centers in MIT and also in Italy, in IIT in Genova. They are developing, for example, 4-legs robot. And these robots are useful as case study for biomechanical principle, for example, principle of locomotion, and trying to understand these 4 legs. And they are hoping that forestry industry or industry, service industry, where it is necessary to have robots able to overcome and negotiate terrains with different slopes, and 4 legs are maybe superior compared to 2 legs. And this is an impressive robot with hydraulic actuators. And it is important to know that many patents on hydraulic actuators, on valves and system to control hydraulic actuators are related to such kind of research. So the side consequence of this research will be related to actuators and to better control for actuators. And then from the other side, we have micro machines and microsystems. For example, this is an insect, and there is a lot of research on that in order to study the biomechanical principle of locomotion. To me, bio-inspired design is like a contemplation of nature. So I quote this from Ramon y Cajal because I was attracted by a human hand, and I started to develop a robotic hand because I thought that the hand is the most impressive human organ, and related to many degrees of freedom, many abilities, many possibility in touching, exploring many functionalities, and it is really a challenge to try to develop a system with the same characteristics. And now we have a whole new robotics, and we know that this, which was called bio-inspired robotics, is now attracting the attention of people and of scientists, because we think that it is important to understand not only what living organisms and animals are doing, but how they do it, and try to reproduce that in artificial system. This is an example of a study from one of my colleagues, Cecilia Lasky. She is studying soft robotics. She is the mother of soft robotics, and in Nature, she took an article on Nature telling her story, where they created prototype by prototype tentacles and the working principle, trying to emulate this, the behavior of this soft tentacle with multi-degrees of freedom, and which has no comparable artificial technology. So it is impossible with artificial mechanical engineering principle to develop a system with the same ability. So the octopus is the paradigm of soft robotics, because the octopus has abilities of doing with arm, with tentacles, locomotion and manipulation at the same time, and has multi-degrees of freedom and abilities that no other system can have. So she developed what is called now soft robotics, and in particular, this is one of the devices and tentacles that she developed. And I think that soft robotics is one of the most promising future development of robotics. In particular, I think that the morphological computation, so the intelligence embedded in the tentacle, the intelligence embedded in the system without requiring any external control, is one of the most fascinating area that is studied now. And in addition to that, we have humanoid robots. Humanoid robotics was attracting a lot of investment, like it's similar to the story of self-driving cars. So maybe 10 years ago, Toyota, Honda, Mitsubishi, other big companies, they were invested in a lot of money into humanoid robots. And there was a competition, strong competition, and also race for patenting mechanism that now we don't know exactly what the outcome is. We don't have humanoid robots around. And so I think it is a sort of failure of robotics. And it's interesting to study why the research and the industrial competition on that stopped, and now the same companies are concentrating on self-driving cars. And humanoid robots are now intended for entertainment, for social and support, and for social interaction. But the evolution of that is on two sides. Cognitive robots intended for developing software and algorithm for controlling, for example, locomotion and manipulation, and also social robots. Social robots are important. Why are important? Because the social robot is a robot which is entering into our house and interacting with us and acquiring social behavior and being accepted by the human subject and providing assistance. It's not only a screen or artificial intelligence, but it is much more because it has a physical embodiment. This was what the artificial intelligence people learned from us, roboticists, that it is impossible to develop something which is intelligent and interact with the human subject without the body. So we need the intelligence and we need the body, and the body plus the intelligence into our society, into our house, is producing something which is socializing with us. And there is an additional step which is related to aesthetics. Aesthetics is related to functionality. So the combination of aesthetics and functionality is producing something which is interacting with us. This is Jibo. Jibo is a robot produced in California, and it's a robot intended to take company and to give company to a human subject, and providing pictures, recipes, and calling people, calling friends, and turning the head towards the new friends entering in the room and speaking and enjoying with the human subject. It is really something that maybe we will have in our house. I don't know. But I am interested in knowing what do you think about that. So the self-driving car, the social robot, the humanoid robot, they are something which can be our agent. And now there is a patent analysis. I suggest you to make patent analysis on robotics, and you find something that here in UK received a lot of controversial comments. And this is on cloud robotics, because the combination of 5G with robotics and artificial intelligence can produce cloud robotics. What does cloud robotics mean? According to people from Google, something which can acquire our identity, so our data, our dreams, our friends, our girlfriend, or data about what we want to do and our attitude or similar, and taking our identity and playing in the cloud with such kind of identity and making something in our place. So that is on that statement. We can outsource our own personal experiences. So the experience will be on the cloud. So this is the basic function of the cloud. The cloud is intended to have some experience, data acquired from sensors, putting all data collected together in the cloud. All the robots in other parts of the world can access the experience. So I have an experience here at Imperial College. Somebody in Italy can enter in my cloud and have the same experience, or switch to another agent and acquire other experience. So this is exactly what I think for the moment cloud is intended for, and there is room for thinking. So robots are coming at our place. And so this is the process that I would like to point out. For the moment, we have robots in the space, so exploring planets in our place. And we have robots producing our vehicles, our systems, our mobile phones. So it is not possible to think about manufacturing without robots. So mass production is related to robots. There is no mass production without robotics. And now we know that there is robots underwater doing jobs under the ocean, and robots in hospitals doing rehabilitation, and in surgical room. So in all surgical rooms now we have robotics. It is not possible to think about a new surgical room without robots inside. But by means of Roomba is a vacuum cleaner produced by Baxter Robotics, by iRobot. They are in our houses. So there is a sort of jump from here to here. Here we are speaking about robots in specialized environment, where people, engineers, surgeons, therapists, or workers are using robots. Now we have robots in our house, so everybody can use the robot. So I want to stimulate your thinking about that. So robots will be maybe our twin. So here we cannot decide who is the robot and who is the author of the robot. Then, wearable robotics. My area is in particular wearable robotics and exoskeleton. And why it is important, wearable robotics. Our main objective is to produce something which is really sharing our intention, our movement, our sensory feedback, our position in the space, our experience. And I quote Lick Leader. You know maybe who is Lick Leader, maybe because he is British, I think. And in the 60s, he was able, in a paper that I like very much, and I suggest to students to download this paper because it is incredibly, I don't know, if he made such a forecast on the future that is really impressive, because he spoke about human-computer symbiosis and predicting what is now the human-computer symbiosis that we have with our laptop. And he predicted that human and computers will become fluidly interdependent and share goals. So this is exactly the objective of wearable robotics, to have something which is wearable in our body or implanted or wearable, and is sharing our objective. And what are the main problems in doing that? We know that we need a compliant system. We need to rely on brain plasticity in order to learn how to produce the movement with the robot. And we need to rely on natural damping. And we need a system which must be intelligent and adaptable, robust, repeatable, high power, and easy to set. High power, this is one of the main problems. And we want to avoid stupid behavior, and we want to have a flexible system which must be tightly but comfortable, lightweight but structurally reliable, strong but transparent. These kind of requirements for mechanical engineers are a sort of nightmare, because it is a paradox. You want something which is tight but comfortable. This is very difficult to obtain. So this is the reason why wearable robotics is attracting a lot of good and excellent students in mechanical engineering because the mechanism to provide such kind of wearability for the moment by means of traditional mechanism is very difficult to obtain. And I will introduce you some of the robots that we are developing, but I want to point out one thing which is important, which is technical but not so technical, that the performance that we now are able to obtain by means of this kind of robots, which are now becoming more and more popular and used in clinical practice, for example, is related to a component, which is the series elastic actuator, which is a motor plus a special spring and some transmission. And this motor plus a special spring plus a transmission is emulating the human muscle, is producing what we call compliance and stiffness when it is required, and when it is required, flexibility and adaptability to the interaction. So the robotics, which was robotics related to producing movement and controlling movement, is moved to interaction robotics. Now robotics, and especially wearable robotics, is related to the interaction between the robot and the human subject. And so the control is moved to address this problem, controlling the interaction between the robotic system and the human body. And now it is possible to develop that, and people around the world and research centers in different centers around the world are competing on that kind of component, the series elastic actuator, which is putting a motor which is very powerful, but the motor cannot be in contact with the human subject and with the human body because it is dangerous. And there is a spring, which is the interface between the robot and the external environment, and this spring plus the motor is producing the behavior of the human muscle. People studying biomechanics understand what I mean. So it is interesting that we are seeing in soft robotics, emulating the human body in the artificial robot is the key of the success. So now I am moving to the main point for design. So we have to develop kinematic design. Kinematics is related to the complexity of the movement of the human arm, of human hand, and we have to emulate that. We have to match the out impedance, so the problem of being transparent in being worn by the subject. The intuitivity, so that means that the use of the robot must be intuitive. And the robot must understand, because if my subject I am using the robot and the robot is not obeying to what I expect from him, I will remove the robot and throw it away. And mass distribution, so the distribution of mass for engineers is fundamental, because if you make a mistake, you will not compensate for gravity, for example. So the mass distribution in the design of the wearable robot must be very carefully studied in order to produce smooth movement and wearability. And finally, tailoring, because we have short human subject, tall human subject, fat, thin, and so one of the problems of wearable robotics is related to how to adapt the robot to the human subject. And this is only to show you the study, the 1 degree of freedom of the human elbow, which is the simplest of our joint, is only 1 degree of freedom, active degree of freedom, and many passive degree of freedom is requiring a 4 degrees of freedom mechanism in order to adapt the movement of the wearable exoskeleton to the movement of the elbow, and a lot of patent and a lot of alignment in order to produce that. It is clear by seeing all these mechanisms, how soft robotics could be powerful in future. Because if we develop a soft system for joint, we will solve in one single design all these problems. So now this robot is studied for spasticity control in human subjects with severe disability, for example, for post-stroke subjects in clinical facilities. And we are now making a lot of trials in hospitals all around the world. And then there is this robot, which is the complete robot, which starts from the shoulder and reach the hand. And this was the robot that I showed you before for teleoperating. And I would like to spend a few words on that, because you can understand the complexity of wearing a robot. So you have not only the kinematic design of the robot in producing all degrees of freedom of the upper limb, but also different control strategy. This is a robot in charge where the robot is producing the movement and the subject is passively moving the robot and according to the robot. This is patient in charge modality, where the subject is impressing the movement and the robot is producing torque at the joint in order to help giving some assistance in producing the movement. The two strategies must be implemented in the same robot. So for the control system, it's very difficult to switch into different control modalities, patient in charge and robot in charge. And this is an example of teleoperation of the robot. Finally, we are developing the exoskeleton for hand, and the hand exoskeleton is really a complex task. So you can see here from that picture one thing which is important, and which is the essence of what I would like to say, that emulating the human behavior and the human kinematics and the control of joints with a mechanical engineering developed device is difficult. So because we don't have the same component, the joint, the tendons, the muscles, and we have cable tendon, motors, and different kind of transmissions. And for the moment, we have to cope with several mechanisms in order to produce from external the same movement and degrees of freedom of the human hand. This is the challenge of wearable robotics. And maybe soft robotics, computational intelligence, and other material intelligence and new materials will produce better kinematics and better devices with more compact and more similar to what the human biomechanics is doing. This is a subject with spinal cord injury who for the first time was able to grasp an object and also make his signature thanks to the exoskeleton. Finally, the system that now is developed by the company, which is an exoskeleton, wearable exoskeleton, producing assistance to the hip joint. So at the same time, he has some passive degrees of freedom in order to produce the alignment and the same degrees of freedom of the hip, and providing some assistance with different control modality to the subject. And the company, the UVO company, is now developing this as a product for personal mobility. Finally, I conclude with bionics, because bionics could be maybe the future of wearable robotics. Bionics is the combination of implantable devices and external devices as prosthetic devices. And we know now that bionics is receiving a lot of attention from the industrial companies, the field, and the medical field. And but it is a long story, okay? And we have a parallel development of interfaces, implantable interfaces, and external robotic system for producing prosthetic hand. Basically, one of the main projects that I followed in my scientific life was related to the brain-controlled prosthetic hand, which is based on the idea of an amputee, an external hand, producing intention, and the prosthetic hand executing the intention and providing feedback and producing perception in the subject. So this area is related to wearing a robot, for example, a prosthetic hand, and controlling this robot with the brain. So producing the total connection, which means a bridge between the robot and the brain, exchanging signals for controlling the hand, so expressing the intention, and also providing the sensory feedback back. And for doing that, we need two things, a dexterous hand and an interface, implantable interface. This is an example of video. And then I will conclude and leave time for questions. This is a human subject with a bionic hand, which is controlled by means of signals coming from muscles. So this is an electromyographic control. And you can see here all the challenges of this kind of research. The subject is looking at the hand. So if we produce the brain control hand, the subject will not be forced to look at the hand, and the burden of controlling the device will be eliminated. So the final, ultimate goal of this research is to producing something which is plug and play. So you put the new hand, connect everything with the nervous system, and the system is working. For producing that, you need an artificial hand, and this is research done in mechanical engineering for doing that, and the interface. In that particular case, my group is working on peripheral nervous system electrodes, which are put on the stump of the human subject, and which produce the sensory feedback and the control of the movement of the hand. And we were able, in an implant in Rome, to restore in a human subject the feedback, the tactile feedback by means of external hand, which means that the hand touched the object, and there were signal processing, and the interface stimulated the stump in the nerves in the stump, and the subject received the feedback transformed into perception in the human brain. So I think that now, for the moment, I stop here, because I spoke a lot and I don't want to be boring. And I would like to answer to your questions, and I put on the floor many issues, and some technical issues, and also mix up with some economical and ethical considerations. So I would like to receive your feedback and understand what is your feeling about what I presented. Thank you very much.
Thank you, Professor Carrozza. We have now time for questions.
I was just wondering, you mentioned that at some point we're going to have microphone.
you just mentioned that at some point we're going to have to add elements of morality into driverless cars, and that there's the issue of the trolley problem of if a car has to choose the better of two evils. Do you have a personal view on how that might be solved, or different people taking different approaches to the element of morality in driverless cars?
Please repeat, because I didn't understand.
Sure. So the question was just into the general morality of driverless cars that you mentioned.
The
And
morality
do you have a
issue,
personal
yes.
view on that?
I have a view. I think that it is true that if we have the driver replaced by a machine, we need some morality in the machine, because decision must be taken. So I think that we can face this problem with a sort of incremental approach. So putting the car in a very simple and single lane, and starting with very simple task and very simple movement, and trying to do step by step. So to me, it is impossible now to throw a machine into the street. In Rome, it is impossible, but I think even in San Francisco, it will be impossible, because morality is a sort of abstract ability or capability. We have to translate into software code, and the coding in that area is very difficult. So I think that we will make some experiments, and step by step we will learn by doing such things. But I have a practical approach.
Hello. My question is also about self-drive cars. Inevitably, I think most people are concerned about that prospect. But my concern is, will all the cars be programmed similarly to avoid accidents? And what happens to the insurance claims if there are accidents?
Yes. I think the insurance problems will be related to civil law. We need lawmakers and civil lawyer in order to develop responsibility regulatory issues in that area. So if we don't solve that, we will never have a self-driving car into the society. But I don't think this is a subject for engineers, but for people studying responsibility and human to human responsibility, human to machine, and machine to human. Who is responsible for that? This is an issue. For example, the European Commission launched this initiative, the Innovation Deals, which is related to exactly to that. How lawmakers must be involved in the process in order to predict what will happen in that area.
But do you envisage no crashes at all if all cars are robotized?
I envisage a lot of pressure, because I have experience of experiments of robots in the small town, for example, delivering some goods in the house by house, and moving into streets. And I know that I have experience in managing and negotiating with an insurance company for the insurance, and it was really impossible. The cost of such kind of insurance was too high. So it's really, I think, the issue. I think it's important that we understand that without solving this, we will never have robots in the street.
Hello, thank you very much for a great lecture. Could I take you back to the start of your lecture, though? The rest of the lecture dealt with robotics. What I was interested in was the artificial intelligence side of things. And it was interesting that we started with a message from Tim Peake, because in the film 2001, of course, there was a very famous artificial intelligence. And I wonder about this idea of hell on earth, if you like, if you excuse the pun. What happens when artificial intelligences are like that Go player, that they recommend decisions for us that we don't understand?
You mean when artificial intelligence algorithm will recommend us recommend us to do something that
Well,
we don't understand?
Yes. I mean, take, for example, a problem that you would throw at artificial intelligence, particularly where you're talking about interdisciplinary thinking of scientists. So you want to decide the most carbon-efficient energy policy for your country. So that's a good thing to do. It's a laudable thing to do. What happens when you get the answer and the industrialists don't like it, and when you can't explain it to your parliament?
I think that the problem is also related to morality, okay? If the artificial intelligence algorithm produce something which makes decisions, we have to introduce some rules in terms of the relationship between human and human, so subjects and the relation between persons. So I think that for the moment we can think about tools providing us some data, but not making decisions in our place. So I would prefer to have a politician, even if the politician is not perfect, to take decisions instead of having a software taking decisions, because I hope that the politician, the human subject, has some morality which I share with him or her. So I prefer to have President Obama and not a software taking decision if attacking or not the enemy. So this is my position. Maybe we can have some big data analysis and producing information, but the final decision. So I decided to sign the open letter against weapons with artificial intelligence able to have the possibility to decide the target. So I joined the scientists all around the world in signing this letter because of that.
Professor Carrozza, thank you very much for a wonderful talk. I think you're in a unique position because you're a scientist and a politician, and certainly in many robotics areas, and I'm thinking medical robotics here, there is an increasing gap between the lawmaker's understanding of the machine and the scientist's understanding of the machine. And so you get into this massive problem of trying to commercialize or legalize the use of a certain piece of equipment. Now, for the life of me, I cannot think how you can shorten or reduce that gap. And I'm wondering whether through your experience as a politician, you have come across a way in which you can somehow make it easier to, for example, receive MHRA or CE marking or FDA approval on equipment that is becoming more and more complex and thus a lot harder for the lay public to understand.
Yes, I think I understand the question. The problem is that a couple of days ago, a person from a company, manufacturing company in Italy, asked me some assistance in order to develop some regulatory issues in order to test with worker, so in the manufacturing company, so worker doing something in the mass production to put a novel device, wearable device, to reduce the workload. Okay? So for the moment in Italy, it's impossible to wear a device which is unknown for the regulations for providing assistance and supporting in overcoming the load of the task. And I am thinking how to help this company because there is no written rule for the moment for facilitating this process. So I will involve insurance companies, especially companies involved in insurance for workers, which are specialized in this field, and people from the parliament and from the Ministry of Industry and Economical Development in order to find together some possible way of addressing this area. Because if we don't solve this, we will slow be slow in the process, and maybe our company in UK or in Italy or in other European company will lose some opportunity. So the reason why I put such kind of introduction in my lecture is to stimulate you and the community, you know, that this is an issue, how we can face this problem, because technology and the technology is making pressure on us, and maybe we will have some positive effect, but we will not have a positive effect if we don't solve this development problem and the relation with insurance. And also regulatory issues and responsibility. I think there is one person here.
I would like to come down to the nuts and bolts of the lecture and your excellent presentation, and ask a question about the production of these very complex mechanisms and control systems. Is it possible to simulate these systems before you go into prototyping, and how effective might that be in expediting progress in this important field?
That is touching one problem of the development of robotics. It is very difficult to simulate. So it is possible to make finite element analysis of the different devices and mechanisms at the small level, but we don't have a multi-layer simulation producing the assembly of the small system of this mechanism into a complex system and introducing the human inside. Because we have some simulator of the biomechanics, but they don't match with the simulation of the mechanical devices. So the only way that we have for the moment is to produce prototypes, and to make some analysis by hand, by equations, by studying the different mass distribution. But I think that there is room for improving this, because even if we want to enter into artificial organs, because of the structure of artificial organs, we have to try to be able to simulate the combination of small elements into a macro function. For the moment, this is unsolved by simulation tool.
You mentioned that some of your colleagues disappear in these companies. And so it seems that there is not sort of an international agreement on how to deal with these existential risks. Also because the militaries of various countries are deeply involved in this. I mean, you say you're a signatory of this. At the same time, you say you trust Obama, somebody who kills with drones. So there is a... I was wondering what steps are being made for sort of an international setup, so that these issues are discussed not in the different academias or different, but sort of in international, as a global basis, as something that affects everyone.
Yes, I was joking. I am a member of the parliament, so I trust the prime minister and the president in taking decision. And but also, I trust humans much more than artificial intelligence algorithms, because for the moment these algorithms don't have any morality inside, and I cannot check what they are doing. I said that some colleagues are disappearing, and this is typical of engineers in robotics, because when you are a professor, you are able to interact with the community and discuss, but when you work for a company, such kind of company, competing so much, you disappear, you cannot speak. So for me, it is important that First of all, we discuss such kind of problems out of the California and Toyota and Google companies. So here in UK, in Italy, in China, everywhere, we have all to make the same effort, because I don't think it is safe for us that somebody in some companies are developing things which such kind of impact, potential impact on the society without any public discussion on this impact. So it is important that we join the discussion and we develop competing things. And there is Elon Musk in USA. He invested a lot of money in this foundation for OpenAI, I don't remember the name, but it is a foundation for supporting people all around the world willing to enter in this area and trying to investigate such kind of issues related to the use of artificial intelligence and robotics in the society. So what we can do is to join this arena and try to be part of this discussion. I don't think we can do more than discussing that in the parliaments, in the scientific communities, in the universities, and try to be part of this. And UK, I think that UK is one of the country of the scientific community, the British community, which is involved very much in this discussion, signing, putting open letters and many other actions in order to be part of this discussion. I don't know if I answered to your question, but I don't have any specific...
Yeah, for example, there is a International Atomic Energy Agency. Shouldn't there be... So, I mean, of course, the discussions are very good, but do we know what's happening in the behind the closed doors? Shouldn't there be sort of an international regulation of what's happening in the various corporates?
Yes, I understand. In Europe, we are very weak, and for example, what we can do at the level of European Commission is to join such kind of initiative in order to try to enter into the system. And also, in America, in the States, the relation between the Congress and what is done in, for example, research agencies or NASA is very close. They know and they control what is done with public funding. I think that also in Europe and in our country, we must enter in this process of more transparency and more control from the public, which is applied through the parliament, I think, into how the public funding is spending in relation to such kind of outcome.
Let's see. You mentioned adaptive... Oh, I'm here. You mentioned robots which will adapt to human wishes or human brain. Isn't there a danger that robots can then, of random variation, which is subject to, say, human emotions themselves change, and a robot can unlearn something that is learned before and lead to mistakes? So what sort of tests there are for detecting that movement is not random, but what is in accordance with a program or something like that?
For the moment, neural interfaces in the central nervous system are only related to the contact with few neurons and the exchange of data for efferent signals or similar. So for the moment, I think the technological possibility for the interface to enter into the brain and cognitive abilities of the subject, I think, is very poor. It is clear that if you introduce something into the human brain and exchange data with the human brain at the peripheral and then central nervous system, you enter in the cognitive process. But I don't think that I'm not a neuroscientist, so it's better for a neuroscientist to answer to this question. But I think that, for example, the use of smartphone or some softwares like Siri or software system able to elaborate your, or Google, for example, elaborate what you are doing on your smartphone or on your laptop are much more invasive compared to neural interface. Much more, because they are entering in your cognitive process and affecting it, as Lick Leader told us. So it's sharing our cognitive ideas. So before, for the first industrial revolution and the second, we were giving to the machine our physical effort. So the machine were supporting us in doing physical tasks. Now the machines are supporting us in cognitive process. So it is impossible that by delegating some of the cognitive process, our cognitive abilities are not affected. But I think there is room for a neuroscientist to investigate on that.
We have time for just one last question.
More a comment than a question. Chiara, thank you very much for the beautiful talk, and the quality and number of questions speak by themselves. Make clear one thing, that when we talk about artificial intelligence, as you mentioned, we are not talking of writing a program which is coded as a von Neumann program, and then you can introduce morality, if and else, and instruction like this. The Go program is something which is based on deep learning artificial neural networks, so something which emulates the way we reason. It's not programmed in a classical way. Just looked at billions of examples. So this makes things even more complicated when you talk about civil issues, regulatory issues, because you can't even prove that you know what you've put into the program, into the artificial intelligence. They learn as we learn. We are far away from having artificial human brain. 100 billion neurons is a little too much for us today, but that's the way we are going. So the problem is very serious. We shouldn't be scared, but it's a very serious problem for the implications, even for driving cars. How can you tell that the car will make the right decision?
Thank you.
Thank you very much, Professor Carrozza, for such a great lecture. And a very big thank you also to astronaut Vittori for being here with us today. On the behalf of the Italian Society, I would also like to thank very much the Italian Embassy, the Hamlin Center, the European Space Agency, and the Imperial College for allowing us to give us this great talk we had today. A special thank to all the society involved in this event, in particular to the Italian Society, the Electrical Engineering Society, the Robotic Society, the Imperial College SEDS, that gave us great support for this extraordinary lecture. I would like to personally thank also Eduardo Vittori, that has put a lot of time, passion, and commitment in helping organizing this lecture, together with all the other crew members you can see here. Without this lecture would have not been possible. Thank you very much.